let's start. So my name is Brian. And above anything else, I hope that this 2-hour session will be a productive one. Okay, I hope you learn something from it, right? So today our main focus will be on more towards differentiation and integration, because these are the two new topics you have learned in Form 5, right? Most of you, I think, should be about at the end of integration in school right now. And your midterms is most likely going to cover that. So our focus will be that. Also, why I want to do these two chapters is because it is one of the, unfortunately, one of the most hated chapters. And it's for a good reason. Okay, it's for a good reason. Because a lot of the time, people don't know how to do application questions. And differentiation and integration actually is very commonly asked in the form of application question. So today, I want to answer all your questions on those application stuff. If you are one of those students who okay, maybe you guys have not answered any exam question on differentiation and integration, but towards trial exam, I'll get asked this a lot. Teacher, I look at a differentiation question, I look at an integration question, I don't know how to start. I don't know where to start. I don't know where to begin. I don't know what to apply, right? I've done all the kinds of questions, but in exam, I just don't know how to start. I don't know what to apply. Sometimes, right, all you have to do is just to look for maybe one keyword. Okay, maybe that keyword is maximum, right? So maybe they can have a very long paragraph of words, but then they never tell you maximum point. I think you guys are very familiar with hearing the word maximum point. You know that differentiation we deal with maximum point, minimum point, and things like that. But maybe in exam, they don't want to give you maximum point. They tell you maximum. They change it up a bit. Profit, for example. Right. So in today's lesson, in today's session, we will see a bit on how do I look at a keyword. And when I read the question, immediately I know, okay, this is differentiation and which part of it. All right. And which part of it. So for circular measure, I think you guys have this notes already. For circular measure, I'll just do a quick go through. All right. I will not do any questions unless we have extra time. But later on, the answers I'll give you guys in a PDF file. Right. So for circular measure, you really just want to focus on a few things. Number one, how to find perimeter. And when it comes to perimeter, your focus should be two things only. How to find arc length, S equals to R theta, and how to find length of chord. Not very common, but sometimes they ask. Okay, chord is this guy right here, right? The straight line that connects any 2 points on the circumference, except for being the diameter, right? Any 2 points on the circumference, you connect. That one is called a chord, except for if it's a diameter, then it's called diameter. But other than that, it's all called a chord. No? So to look for this chord, you can either use cosine rule or this formula. Some people like to use this. All right. So focus on these two things. You know how to do these two things, you should be able to find perimeter. Finding area, on the other hand, you have area of sector, triangle. This one you all learned last year. Sometimes it could just be half times base times height. Okay, half times base times height. And then if I want to find area of segment, usually I like to call this the pizza, right? Sector is the pizza slice. Okay, you got the radius, you got the theta, you confirm can find. The triangle is what I call as the ice cream cone. The segment is the ice cream part only, right? So the segment, if you want to find the ice cream part only, there's no special formula. Maybe you feel like your teachers taught you a special formula, but really, it is just a combo of a sector minus a triangle. You take a pizza slice, you minus off the part that you don't want here. You will get this. And this shape has been quite popular. This shape has been quite popular in the last, I would say, 5 years in SPM, right? Or in the state papers as well. Formula-wise, from my experience, usually students are quite comfortable with this chapter. Okay, usually among the other chapters, usually they are quite comfortable. But I want to highlight on one thing, something that your textbook don't tell you, something that a lot of teachers don't tell you, but you will notice in, let's say, 90%, okay, 90% or 85% of the past year paper, they will deal with some form of triangles. Anytime when you deal with circular measure questions, very commonly there's a triangle involved. Very commonly there's a triangle involved. Most popular one is this one with a double star. Right angle triangle. Right angle triangle. Right? It's not in the syllabus. Right? It's not anything new. It's because it is taught in Form 3, Form 2 that time, right? You all learn about right angle triangle in Form 3. You all learn about Pythagoras theorem in Form 1. That's why it's not in the textbook, and your teachers don't emphasize it. But in exam, it comes out a lot. Sometimes it's the part A, you know. Maybe they ask you to find out a certain angle, right? Maybe they give you something like this, right? And then they say, can you go and find out the angle and stuff, all right? So if it's an isosceles triangle, you can always make it a right angle triangle. But my point is, trust me about this, trust me about this. Whenever you get stuck in exam, okay, I know now you guys don't feel that it affects you that much because I think you all haven't sat for an exam that has covered circular measure, but midterms, okay, your midterms is going to come. Say, let's say you have a 10-mark question, you want to try the start, very excited, you want to apply s equals r theta, very excited, you want to apply half r squared theta, and then you suddenly realize you cannot find the angle in part A, just 2 marks only. Okay, you know you can do the rest, the 8 marks, part B, part C, part D, you know, but just the front part, okay, you realize you cannot do. This is when you think of your triangles. Trust me about it. Okay, trust me about it. You go and look at it. Do you think you can get a right angle triangle or not? Maybe then you can use SOHCAHTOA. Maybe then you can use Pythagoras theorem. Usually it's this two. Okay, usually it's this two. So right angle triangle is very helpful in that sense. Okay, another important one is equilateral triangle. Later on, you're going to try and see this question. They never give any angle. They just give you some lengths like this. But you will, and then they never tell you about length of arc. They never give you about area and stuff. You need to figure out yourself what is the angle. Okay, you need to figure out yourself what is the angle. And sometimes it could just be everybody having the same length. And therefore, all their angles are the same. They are all 60 degree. You just split your 180 up by 3. All right. So yeah, so think about your triangles if you get stuck. Okay. I will not go through question 1 unless we have extra time. I will go into chapter 2 straight. Okay, so somebody asks, teacher, can we use modern maths formula in F maths? I highly do not recommend it. If you are thinking, can we use this? Okay, instead of using this arc formula, can we use this? Or instead of using sector, can we use this? I highly do not recommend it. Why? Because in circular measure, you learn a new angle unit called radians. Okay, the purpose of learning radians is because you need to use radians in this formula and also in this formula. Okay, so the marking schemes are usually looking for that formula, right? And you may be able to still get the answer, but I still highly do not recommend it because a lot of teachers don't accept it. Okay, I highly do not recommend it. Use the formulas that you learn newly in this chapter. Practice a bit, get comfortable with the formulas. All right. Okay. So yeah, later on I'll give you all the solution for this. When you have the time, you can go and try and see. But I want to do chapter 2. Okay, chapter 2. So if you are sharp, you will notice that, hey teacher, this is not everything I learned also. Where's the Mr. Lim? Mr. Lim is this guy. The limits, the limits, right? You all learn about limits, I know, right? You all also learn something called first principle, but I didn't include here. Why? Because I think those questions that is talking about limits and first principle, you look at the examples in the textbook enough, right? Do they come out very often? I would say out of 20 years in SPM, come out one time, 2 marks only, limits, 2 marks only. Okay, so even though in SPM it's not that popular, but in school exams, sometimes your teacher want to play with you, ask you all this stuff. But in my opinion, questions like this is like, if you know, you know. Why do I say that? Because they cannot twist and turn a limits question too much or first principle question too much. So if you know how to do, you should be able to do it in exam also. So you just look at the example in the textbook. It's quite good, the example there. You know how to do and should be okay already. You don't have to worry too much about them changing these questions into an application question because limit cannot change. Okay, limit is just like that. So it's quite straightforward. The not so straightforward one is the applications. Okay, the applications. I make your life very easy. I'll tell you straight up, there are 5 applications. Okay, there are 5 applications. Whether you know this or not before, now you know. Okay, and it is very important because almost all 5 will be tested every single year in SPM. Almost all 5. Sometimes they test 4 out of 5. Sometimes they test 3 out of 5. But usually almost all they will test. Very popular. Very, very popular. And I will teach you today how to look for keywords. In a question, when I see tangent, when I see normal, I will know that they are talking about this. I will know that they are trying to tell me that, or at least I need to apply the knowledge of dy dx is always equals to gradient of tangent, right? And mn is always -1. Okay, I'll just draw a quick diagram. I'll quickly go through this, all this stuff, but later I'll teach you how to apply when we do the question. So this is my curve, tangent. Usually people are quite good at this, this tangent normal stuff. Most people are okay with this, right? So you know, normal and tangent, they are 90 degrees. So their gradients, when you multiply, is always -1. Question. Can dy dx ever be equal to the gradient of the normal? No? Can this ever happen? No, right? It can never happen. Gradient of dy dx, which is the gradient of the curve, is always the gradient of the tangent. Please, yes, tangent. It has to be tangent. It can never be the normal. Please do not mix this up. Okay. Dy dx is forever gradient of tangent, but you can easily convert it to gradient of normal. Next one. When I see all these keywords, turning, stationary, inflection, maximum, minimum, I'll think dy dx equals to 0. F prime x equals to 0. But later I will teach you guys how to do those questions where they never say turning point. They never say stationary point. They never say maximum point. Like just now I show you at the start. Maybe they say maximum profit. Maybe they say minimum cost. Okay, maybe they say maximum area. How to answer this kind of question? Okay, how to answer this kind of question? Because turning point, we all know. Maximum point, we all know. Just differentiate the curve only, and then equals to 0. Then can solve it. But what about all this? I got no curve to differentiate. What should I differentiate then? Okay, later we try. Later we try some of these questions. Number 3. You know, many people mix up this two. Many people mix up number 2 and number 3. You must have a very clear mindset of when do I do number 2? When do I do number 3? Okay, I do number 2 only when I see those keywords. I see those keywords, I immediately know I should do number 2. It should be that, right? 99%. If you know it's differentiation, it should be that. Number 3 is only when you are interested. I already know this point is turning point, but I don't know this point. Is it sad face? Is it smiley face? Or is it half a sad face? Half a smiley face. This half smiley, half sad one, we call it an inflection point. Okay, we call it an inflection point, right? So if you already found out your turning point, but all you want to know right now is whether are you max or min like this, then only you go and do your second derivative. Okay, then you go and do your second derivative, which is d squared y dx squared, meaning differentiate 2 times. Differentiate 2 times. The only purpose, only usage of differentiate 2 times is to find what type. Are you maximum? Are you minimum? If you're interested to know that, okay, then you use number 3. Okay, then use number 3. Number 4, keyword is rate. I see rate. If chain rule is not in your working, confirm I know you did something wrong already. Confirm. If I see the word rate and there's no chain rule in your working, 100% wrong. 100% something has gone wrong if you didn't apply chain rule. In some way or another, you have to apply chain rule. All right, you have to apply chain rule. Okay. Lastly, the keyword here is if I see the word small change, if I see approximate change. But you all don't be so rigid lah. Don't be so rigid. Any synonyms also can. What's the synonym of approximate? Estimation lah, right? Estimate also same thing, right? You will say that the delta y over the delta x is very similar to your dy dx. Okay, how to derive this? Today we don't have time to go through, but we learn how to apply it. I think that's more important. Okay, I think we learn how to apply it. So I'm going to start with the first question. And along the way, we will tackle one application at a time. All right. But I want you guys to know this. You know, a lot of the time, differentiation is a 10-mark question, or it's usually quite long, usually quite long. Integration also quite long, most of the time. So the problem with many students is, maybe got one student, I'm so good with 1, 2, 3, 4, 5, right? I know all the applications very, very well. I already know exactly what to do for everything. But sometimes we underestimate, or rather sometimes we overestimate ourselves with how to differentiate something. Okay, how to differentiate something. So, you know, why I say we overestimate ourselves is because I've seen many papers from students. They always differentiate something wrongly. Maybe they accidentally plus or minus the power wrongly, because you need to switch from differentiation to integration very well in exam. Sometimes you just careless a bit only, but everything else you did correct. You know rate of change, you go and do chain rule. You know a turning point, you go and find dy dx equals 0 and all that stuff. You know how to do everything. It's just the front part, the first step already wrong. So how our first step already wrong? GG.com, right? Too bad lah. Everything will be affected. So I got a quick question for you guys. This one, if I go and differentiate it, do I need to use quotient rule or product rule or not? Simple question. You just type yes or no. Okay. Do I need to use the product rule or quotient rule for this? What do you guys think? Wow. Okay. You guys gave me oh, most of you say no. Okay, very good. Yes, most of you said no. Most of you said no. Yeah, very good. Most of you said no. But in case anyone you are shy and you're not sure about the answer, or you think that I need to use quotient rule, let me tell you why you don't need to. Okay, why you don't need to. So a quick one before we start to do application, I just want to make sure that your quotient rule, product rule concept is correct. You always think like this. Is my equation, or rather, does my equation look like this or this? Okay, one more very important thing, where both u and v have x. Okay, both u and v have x. I think you all know what is u and v, right? Because when you learn differentiation, we always say, okay, maybe if you have a fraction, the top part we can call it u, the bottom part we can call it v. But both have u and v have x, then only I will do product rule or quotient rule. Then only I will say, okay, this one I will do u and differentiate the v prime plus v and then differentiate the u. Okay, and then for like this, if both u and v also have x, then I will use this formula, vu prime minus uv prime over v squared. This one, unfortunately, you need to remember lah. They don't give you the formula. Sometimes we can write it like this also. Same thing, guys. Same thing. If you see an apostrophe, it means differentiated version. Okay, you see an apostrophe means differentiated version. I usually like apostrophe. Looks simpler. You can use in exam, no problem. Okay, so if you are someone who get confused, very simple question to always ask yourself first. Is this a u and v situation? On top, u is equal to 3. At the bottom, v is equals to 2x plus 4 to the power of 5. Don't have x here, right? Highlight here. Both u and v have x, only I will use my quotient rule and product rule. Don't have x. It's just a number. Don't have to worry about number. Okay, don't have to worry about number. So same thing like this. If I give you a 1 over 2, 4x plus 3 to the power of 4x squared plus 3 to the power of 3. Okay, some people say, oh, teacher, the u I want to do 1 over 2. The v I want to do like this. You can go and use the rule, but I tell you that it's going to be a waste of your time. Redundant. Okay, a waste of your time. So don't need. Why? Because you don't have x. Can see not? So u and v got x, only I will use the rule. Okay, u and v got x, then only I will use the rule. So if you're supposed to use the rule, then you must use lah. If here got an x, let me put 3x here like that. This one you have to use your quotient rule. You have to call it u and v already. What if you don't? If you don't, then confirm wrong. If it's supposed to be UV, you have to do UV. If it's UV, both also got X, must use quotient rule, got no other way. If you don't use, then confirm your answer's wrong. Okay, so same goes to here. If I put an X on it, okay, my U is X over 2 like that. Then you must use your product rule. Okay, so first thing to ask yourself, does both U and V got X or not? Because the problem I always get is a lot of students simply use the product rule, simply use the quotient rule. So both U and V got, then I must do. But if don't have, don't bother, right? Don't bother. So first thing is to ask yourself this. Then second thing, if it is not UV or U over V, where both U and V got X, then what do? I will do what I call as the 3 steps method. Okay, then you have to do 3 steps only. First step is you take your power and you multiply. Second step, you take your power and you minus by 1. Third step, you multiply by your bracket, but the differentiated version. Quick example. This one. Okay, watch out. This one, I know, first thing I'll ask myself, is this U and V or not? No, because this guy don't have X. This is the U, this is the V. Okay, the U got, but the V, sorry, the U don't have X, my bad, but the V got. Don't need to use quotient rule. I use only when both got. Okay, so if don't have, then what? Don't need to think already. Straight away, number 2. So differentiation is just like this. I always need, first thing I'll ask myself, always, got U or V or not? Don't have, then confirm number 2. Like that only. It's either one of them only. There's no number 3 already, right? Got UV, then you do the UV method. Don't have UV, then you do this number 2 method. Okay. So let's try and see. Step number 1, I will take my power and multiply. Multiply to who? Multiply to 1 over 2. Step number 2, I will take the power just now the power 3, I would minus by 1. Okay, power times power minus. And then this B prime, right, is basically bracket prime. Bracket. You see, I've been ignoring my bracket. This is my bracket. I'm going to take my bracket. I'm going to differentiate my bracket because got apostrophe. Anything got apostrophe means differentiate. So I'm going to differentiate my bracket and multiply it. So I differentiate my bracket, I will get 8, okay, power times power minus, plus you differentiate 3, you get 0. And 3 steps only. Make sure you do the steps in order. Power times power minus times the bracket prime. In short, I like to write like this. Okay, in short, I like to write like this. But I just want to do a quick one, right? Not all the time you have bracket, right? What if sometimes you don't have bracket? Let's say y equals to 1 over 2x power 4 minus x to the power of 1 over 2. Okay, let's try to differentiate this. So I'll do power times 1 over 2 times 4. Use calculator. Use calculator. I know some of you are not good with fractions. Power minus by 1 become 3. This one for what? This B stands for bracket. No bracket, ignore this step. Got bracket only you do. No bracket, just ignore the step. Then you repeat again the same thing. Power multiply. Multiply. And the power minus by 1. 1 over 2 minus 1. Negative 1 over 2. There you have it. Okay, since I'm here, I want to one shot make sure that your integration is good also. Quick one, so this is differentiation. I hope you all know integration is the total opposite of differentiation, right? Okay, integration is the total opposite. So total opposite, power plus power divide. You see, minus will become plus, times will become divide. But I say total opposite, meaning the steps also have to swap, the order also have to swap. So you cannot just say minus will become plus here like that. No, right? The steps also has to swap. Yes, yeah, minus become plus, and the step also swap. Times will become divide. Okay, then the third step left, divide b prime. Here, integration into the opposite. Sorry, times b prime, you write divide b prime. That is your integration steps. Okay, that is your integration step. I give you a quick one. Then I'll start doing questions. So let's say dy dx look like look like this. When you integrate, you're going to go backwards. Huh? Differentiate y, give you dy dx. Differentiate dy dx, give you d square y dx squared. So now what if we go backwards? Whoop. That is called integration. Okay, that's called integration. So now we go backwards and find out the y. So I'm going to integrate this guy. And then when I do the integration, I follow the step one by one. I'll take my power. The power I focus now is 3. And I'll plus the power first. So you copy, 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 copy. Remember, your focus is to plus the power. You don't care about anything else. You must follow your steps. Plus the power first. It will become 4. And then you divide by the power. Divide by 4. Okay? And then after that, you divide by b prime. So you go and differentiate your bracket if you got a bracket. Differentiated is 4. You normally you write times 4 like that for differentiation. For integration, you put divide by 4. Okay, so divide means you put at the bottom of the fraction. Multiply means you put at the top of the fraction, right? This one table, if you know how to write it, you just have to write 2 times. One time in paper 1 in front, one time in paper 2 in your formula sheet there. Anytime you need to differentiate, integrate, you follow the steps in order, and then you will not make mistakes. You will not make mistakes. Trust me, very easy to make mistake, especially in your first midterm exam. Okay, I'll speak in by experience lah. You know when we do, when you learn differentiation, right? The whole chapter you keep on differentiate. You get more and more confident, you see, because every time you do the same thing, differentiate only. And then when you learn integration also, you just keep on integrate. So you become very pro. Exam the time, it will mess with your mind because one question is integrate, one question asks you to differentiate, one question asks you to integrate. Suddenly you are not used to swapping, you see. So what do you need to depend on at that time? And then you are nervous in exam, right? Exam, you get nervous. You depend on your table. Okay, you depend on this very simple table. It takes me 5 seconds to write this out, right? And I just know how to write differentiation. One can already. Integration is the total opposite. The steps have to swap. Remember that. The times will become a divide. The minus will become a plus. Okay. Also, integration got no such thing as quotient rule, product rule. So don't have such thing as u over v, u times v, that kind of stuff. It's not in the syllabus. Okay, so integration, very simple, just like this. Okay, yes, it is very common. You ask a very good question. Very common in one question in SPM. In fact, it's one of the most popular differentiation integration question. 1 10-mark question. Part A asks you to do differentiation. Maybe asks you to find equation of tangent. Part B asks you to go and do Part B asks you to go and do integration. So they can mix in a single question. They can mix the 2 chapters. So you need to know how to change. Oh yes, sorry. Thanks for reminding me. I forgot a plus C when I integrate. Yeah, I forgot a plus C when I integrate. Okay, then this one, you just use your calculator to help you to simplify. It will become 1 over 32. Okay, sorry, a bit messy. Now let's start to do our questions. I am assuming that everyone is okay with integration and differentiation because we will now straight away go and do some application already. Okay, question number 1. The normal line to the curve at this point is parallel to this straight line. Find the value of A and B. Okay, sound a bit confusing. Huh? When sound a bit confusing, you draw a very simple diagram. Draw a random curve. Okay, differentiation always will have tangent line. Draw a tangent line. Okay, so the tangent line at this point look like this. Right, this is the template that you can always use. Whenever they talk about tangent normal, you can always use this template. Draw a random curve. You don't have to, it doesn't have to be this. Don't have to worry about the same curve. Just draw a curve, draw a point, draw a tangent there first. Okay, then if they want a normal, you draw now one line that is 90 degrees to the tangent. This is the normal. Okay, so we read again. The normal line is parallel to this straight line. The normal line is parallel to a random straight line here. Got one straight line called x plus y minus 8 equals to 0. Okay, I think drawing it helps. So it is parallel to the normal. The moment they say parallel, I want you guys to be really sharp. Parallel talks about same gradient. Yeah, parallel talks about same gradient. Yes, very good. Same gradient. In coordinate geometry also, you have to be very sharp. Parallel, same gradient. Perpendicular, then the gradient would be m1, m2 equals -1. All right. So, and we know differentiation like to talk about gradient, right? Differentiation like to talk about gradient because differentiation means gradient of tangent, gradient of the curve. So I'm going to do something like this. Y equals to -x plus 8. I go and rearrange it first. Okay, I go and rearrange it first. Okay, now let's continue with the curve then. So question, how to start lah? How to start lah, right? First thing in my mind, I know they talk about normal, talk about tangent, all this. I know which application they are talking about. This one. Okay. And then they talk about normal line and stuff also. So I think I need to relate the normal line and the tangent line together. Trust me, you'll be applying this at some point. Okay, trust me, you'll be applying this at some point. Let's see. Okay, let's see. So don't know where to start. You know, confirm differentiation, what to do? Differentiate first. If you don't know where to start, differentiate first. At least get a mark there. So let me rewrite my curve nicely. We always bring the x go up, right? Okay, or if you know how to differentiate very fast, okay, the one up to you. But most people would bring the x up so that we know the actual power of the x. If the x height down here, you would think, oh, it's power 1, but it's not, right? Okay, it's power -1. Let's differentiate. Differentiate is power times power minus. Got no bracket, power times the 2 times. The 2 minus. Okay, power times power minus. Next one, power times become -b, power minus. Okay, you can write it like this. Also can. Okay, and then they say, I think because they gave me this point, I'm going to find out what is the gradient because I know same gradient and all that stuff. So let me try and see to sub in x equals to 1. Okay, when I sub in x equals to 1, I will get the gradient at that point. Okay, I'll get the gradient at that point. You can write dy dx, or you can write mt straight away. Remember, when you sub anything into dy dx, you are looking for the mt. It's never the mn, never the mn. Okay, I think everyone should be able to get this because this question is actually quite common. Normally, we always like to sub in a point, find mt. But you must remember dy dx is mt. It's never ever mn. Okay, how to continue? I got my mt already. We haven't done anything about this line, right? But since this purple color line, these two, they are the same gradient, they are parallel. Can I say that the gradient of the normal is actually equals to -1? Right or not? Right? The gradient of this line is -1. What from y equals mx plus c, because it's just a straight line. The gradient of the normal also parallel, so same gradient. Hey, sorry, guys, mn, my bad, mn. Okay, sorry. If I make mistake, you tell me, listen. Okay, mn, okay, -1. I'm still stuck on how to continue. Then I start to think, I know, see whether I can use this or not. I think we can use this, right? I think we can say, you know what? mt and mn equals to -1. Since I also found out mn is -1, okay, let me use that to find out my mt and c. -1 divide by -1, I get 1. How come I want mt? Because here also is mt. Here also is mt. I can go and equal them already. mt is equal to the mt here. Can or not? Can see or not? Right? So I didn't lie to you. Am I right? Both of these also I use, right? Both of these will be part of your working. So at least it gives you some guidance, right? You don't make careless mistakes. You don't simply write dy dx as mn, right? Dy dx is always mt. Okay, we are still a bit stuck here because I want to find the values of a and b, but then I only get like that. What else can we do, guys? What else can we do? Yeah, can I? Yeah, very good. Can I sub in the point, this coordinate, into the curve? Okay, the next question that I'll get asked a lot. Teacher, why you sub into the curve? Why cannot sub into this straight line? You open your eye big. You see the coordinate 1, 5? Is it on this straight line or not? Okay, is it on that straight line or not? Is it on x plus y minus 8 equals 0? If it's not on that line, you cannot sub in. You can only sub it in if it's on the curve, or if you have the tangent line, you can sub in the tangent line, or you have the normal line, you can sub in the normal line. Okay, so you can only sub it into which equation it lies on. Huh? Which equation it lies on. So I'm going to sub 1, 5 into the curve equation. Okay. So we have y equals to y is 5 plus b over x. At this point in Form 5, you all know already, MS like to do this, like to give you all these unknown. When you have two unknown, you need two equations to solve it. We do simultaneous equation. Okay, we do simultaneous equation. Shall I just make somebody the subject here? Shall I just make maybe A the subject here? And then or B also can. It doesn't matter, huh? Doesn't matter. I move the A over, then B is equals to 5 minus A. Let me call this equation number 1. Let me call this equation number 2. And we try to solve our equations. Okay, it is not an easy question. I have to say this is quite a tough question. It is from the MRSM paper last year. All the questions are from the one or two latest state paper, okay, or from the SPM paper. So all are actual exam questions. Okay, sub 2 into 1, you have 2b minus a equals to 1. All this you'll do yourself, huh? You'll do yourself. 6 divided by 3, I get a 2. Right? I know I do a bit fast here, but slowly times in, and then all this move around one. I don't want to spend too much time. Okay, I trust that you all know how to do simultaneous equation. Okay, can I? So plus become minus, times become divide, that kind of stuff. Okay, lastly, we sub this into maybe equation 2. And that's how we get it. Okay, that's how we get it. Can? Okay. Shall I move on? So the highlight here is to understand that they talk about normal, talk about tangent, and I will apply this in my working. Okay, I'll apply this in my working. Now in question 2, they say that the equation of the curve is like this, and then a straight line will touch this curve at a point. Find the equation of the straight line. Don't know how to start? Draw. Okay, draw out. You have a curve. They say got a straight line that will touch at one point only. Any line that touch one point, never touch, okay lah, we know never touch, but any point, any line that touch just one point, itulah kita panggil tangent line, right? Only tangent line will touch one point. Okay, only tangent line will touch one point, and they say this point is called K, which is 3, -9. Now, they didn't mention the word tangent. From my own understanding that touch one point is tangent, I figure out that, they actually asked me to find equation of tangent, right? So equation of tangent. Now, we go and do dy dx, right? Don't know where to start, differentiate first. Okay, same thing, power times power minus. Power times power minus. Differentiate negative 12x. Same thing, power times the power minus. You get this. Oh, somebody asked me, the normal line will touch one point. Actually, if they use the word touch, it's usually tangent, because if they use the word intersect, then it can be any line, like all this, not only the normal line, it can be a lot of lines. So of course, this one comes from a bit of experience also, because somebody asked me, normal line also cut one point. Yeah, but normal line, we say it will cut through one point, it will intersect through one point. But if just touch only, usually is tangent. Okay. Right, we got my dy dx already. Guys, you want to find any straight line, what do you all need? You always need two things. Gradient and a point. Any straight line you need. This is a knowledge from coordinate geometry. As long as you want to find a straight line, whether in mod maths, whether in ed maths, as long as you are looking for a straight line, tangent is a straight line, normal is a straight line. You always need the gradient and a point, a suitable point that is on the line. Okay, we have the point already. The gradient, please lah, you don't go and use gradient of normal. You want to find tangent, please lah, go and find the gradient of tangent. Okay, So I know dy dx is gradient of tangent, right? I'm going to find the gradient of tangent at x equals to 3, okay, at this particular point on the curve. Okay. This one we get a 15 for the gradient of tangent. You see how when I do, I'm very clear what I need. Tangent is a straight line. I need the gradient. I need the point. Okay, I need the MT and I need the point. Both also I have already. Okay, both also you have. Now you can use this one. You want to use y equals mx plus c also can. Okay, but you can use this. You can say it's y minus the y coordinate equals to, so the gradient is equal to 15. The coordinate is 3, -9. And then x minus 3. Okay, now, so you get y plus 9 times in the 15. Move the 9 over there. Okay, minus 49 and minus 9. There you have it. This is the equation of your tangent. Okay, part A. So again, it's the understanding that dy dx is your MT. You need your gradient of tangent. You need your dy dx to go and find it. Okay. Can you all tell me what is the keyword in part B? You read that 2 sentences in part B. Very short question. Huh? What do you think is the keyword? Ah, very good. Minimum, right? The keyword is minimum. Very important. Minimum. You all have to be very sensitive to this word. But if minimum, next question I want to ask you, should I go and differentiate the x or the y or the p? What do you guys think? Because normally we always do dy dx, meaning I go and differentiate the y. In this case, what should I differentiate? Who should I differentiate? Okay, if you're starting to doubt yourself, if you're a bit unsure because you rarely see this kind of question, yes, it is P. Okay, those who answer P, very good. It is P. It is P. How come I know? Minimum value of who? P. Can see or not? P. So later on, you will start to see questions like this. Just now I say, when they talk about maximum profit, who is maximum? The profit, the profit. I will go and differentiate the profit list. Maybe they call the profit as P. So who you need to differentiate, you must be clear. Because maybe you have a few equations. Maybe you have a few equations, right? Maybe you have a few equations. They say maximum profit, differentiate the profit. They say minimum cost, differentiate the cost. They say maximum area, differentiate the area. If you don't have the area equation, go and make the area equation. That is how I know what to do, how to approach the question. Just looking at one keyword and its minimum, maximum what, differentiate that thing. Okay. Okay, somebody asked, how do you know the question 1 equation of tangent? Because they say the straight line touch the curve at one point. Okay, a straight line can only touch the curve at one point if it's a tangent. Cannot. If touch one point, it's called tangent. If intersect or intersect like that, then it's not tangent anymore, right? That's how I figure out for part A. For part B, okay, so next thing, now I'm very excited. I want to differentiate this because they say minimum P, differentiate the P. I will go and do differentiate the P in terms of, okay, if you write like this, meaning differentiate the P. Okay, down here, we usually say with respect to X or in terms of X, right? But guys, here got X and Y. So can I do dP dx straight away or not? Okay, can I do dP dx straight away or not? Or should I be doing dx or should I be doing dy or can I do both? Or what should I do before that? What happens when you have two unknowns? You cannot do both. Okay, those who say both cannot always remember. You want to differentiate, you can only differentiate one unknown, one variable only. So you have to do something special. You go and take this equation. Okay, you make something the subject. Like this. And then you go and sub inside here. Okay, this X, you go and put inside here. It can be X or Y, doesn't matter. You sub inside here. The whole point, right, is that you cannot have too many unknowns. You can only deal with one type of unknown. Do you see everything become y already? Everything now become y already. Okay, everything now become y already. That is what we want. I cannot differentiate x and y. Either x or either y only. So if you've got too many, you always use another equation to substitute it away. Okay, so yeah, maybe I should write properly. I should call this equation 1, equation 2, and then write sub in. Or maybe I can write here, equation 1, equation 2, sub 1 in 2 here. Okay, now we continue. I think maybe we expand first, huh? Maybe we expand first. This is going to be 16, 4 squared, 2 times a times b. 2 times a times b. 2 times 4 times negative 2y. That will give me negative 16y. Okay, 2 times a times b. Last one, negative 2y when I square it. Anything you square will be positive, guys. Okay, then this y times in, times in. Okay, let's go and group all the square together, huh? I will get y squared. Let's group all the y together. Use calculator, huh? Use calculator if you not so good with mental calculation. That's why you have your calculator. Your calculator is your best friend, sir. Make use of it. Okay, I've now finally made my p look very nice. Have I started differentiation? No, but at least I know exactly what to do, you see. At least I know exactly what to do. From the start, I already knew I was going to differentiate the p, and then I'm not going to do dy dx equals to 0. I'm going to do dp dy equal to 0. Okay, differentiate p, then you go and equal it to 0. That's why it's not always dy dx equals to 0. Okay, it's not always dy dx. In this case, it would be dp dy. Okay, dp dy, which means you differentiate the p with respect to y. Next very common question. Teacher, I don't like dp dy. Can I write dy dx or not? Cannot. You must learn how to write properly. Who are you differentiating and what are you differentiating? You must learn how to write that properly. Okay, because it will also affect how you do your rate of change questions later on. It's important to know who is on top, who is at the bottom. Very easy only, you see, dp dy. Because really a lot of students ask me this, that's why I'm highlighting all these questions to you guys. So if it's the same question that goes across your head, you must write properly dp dy. Now we differentiate. Power times the power minus. Okay. Same thing. The gradient of negative 12y plus 16 is just negative 12. Differentiation is fine gradient, right? So just negative 12. Okay, done already. Now what? The highlight of the whole part B is this, equal to 0. Okay, by the time you reach here, most of the job would have already been done. But we read again the question, they say they want minimum value of P. So you go and find the P. Go and find out P. P is where? P is right here. Okay, P is right here. I will sub into sub y equals to 6 in equation 3 to go and find out the P. Okay, the P that you get right here will already naturally be the minimum P value. P could be anything. Maybe P is the perimeter of something or what like that, right? Or it could be anything. It could be anything, really. So in this case, I got minimum P value as negative 20. So one keyword has lead me to know that I need to do this. From my knowledge of differentiation, I know I cannot differentiate too many things. Okay, I cannot differentiate P like that. Cannot. So I substitute first. Okay, so that everything got no more X already, only left Y. Then only I start to do my dp dy and stuff. Okay, but this step, I didn't lie to you, is confirmed that one. Just looking at that one keyword. Huh? Okay, shall we move on? Yes, somebody asked, if you differentiate dp dx, yeah, so maybe some people convert this equation to p something and then got x in here. Then you do dp dx, you are going to get the same answer. Okay, you are going to get the same answer. Y is equals to 0. Really? I don't think so. Y is confirmed equals to 6. Okay, so you may get a different x value. In fact, I can tell you what the x value you should be getting. The x value should be -8. Okay, those of you who go and do dp dx and then equal to 0, the x value should be -8. Okay, and then you will get the same minimum value of p. Can I want to move on already. If I'm too fast, you'll let me know. Okay, no, now the speed. I know the moving around, expand, plus together, those I'm doing a bit faster because I think you guys are okay. But you guys get what I want to highlight. Each question, I'm trying to highlight the key points for you. Okay, Ken. Next one, number 3. Question A. Quick one. What is the keyword? What is the keyword? Question A. Turning point. Keyword is turning point. Very good. You see turning, stationary, maximum, minimum, inflection. That is your keyword. Okay, that is your keyword. What should I do if I see the word turning point? In my head, I think I am going to differentiate and equal to 0. Okay, in my head, I think I'm going to differentiate and equals to 0. So this is the general version, but we know not all the time is dy dx. Sometimes it could be dp dx, dp dy, like the previous question. Okay, but I hope you all know the word gradient function means dy dx. It's like the equation for your gradient like this. So they tell you dy dx is equals to this. And then they say, the turning point is here. Find the value of p. I already have dy dx, but let's say you are lost, but you know about the keyword. You know about the keyword. Then what should you do? Follow the keyword. Follow what you were thinking of doing already. Yeah, correct. Very good. Right, just now I already say the keyword tell me to do that. So I follow, I do that because I'm lost. I don't know what to do. So let's just try and see. X is equals to 2. Okay, but the turning point, when we say the turning point is at x equals to 2, this x is the same as this p, you see, because the turning point happened at x equals to 2. And then here they say the turning point happened at x equals to p. Okay, the x coordinate is p. Meaning p is equal to 2 because p is the x coordinate, and then we have the x coordinate here as well, right? Question number 2. Okay, part A2. This one you all will see, they will ask you whether is it maximum or minimum. Whether is it maximum or minimum. Whether is it maximum or minimum. This is when you go and pull out your second derivative. Okay, you go and pull out your d squared y dx squared. Okay, if you are unsure, you always refer back to here. Whatever I'm saying is always leading back to here. Okay, I'm using application number 3. Whether is it maximum or minimum. If you are not interested to know whether maximum minimum, then don't do d squared by dx squared. Differentiate. Differentiate 8 is just 0. Differentiate this, you get power times, the 3 times, and then the power you go and minus by 1. Okay, you get like that. And then you want to know what kind of turning point at x equals to 2. Okay, so this coordinate is 2, 3. I don't know whether this guy, is it max or is it min? So I'm trying to test on this point. So I'm going to sub x equals to 2. I'll sub into here. Because you are trying to test that point. You want to know whether that point is max or min. Okay. Now, if it's negative value, you can make your conclusion and say like this. Okay, this guy is negative. When you are feeling negative, okay, today I'm feeling a bit negative, I will put on a sad face. That 0.23 is a sad face. A lot of people think negative is minimum. No, you have to look at the shape. When I'm feeling negative, when I'm feeling down, I will put on a sad face. Okay, when I'm feeling positive, let's say I get positive 12, I'll put on a smiley face. Okay, so what if I get d squared y dx squared? I don't get positive, I don't get negative, I get equal to 0. Then how? I'll get maybe half a sad face, half a sad face, half a smiley face. Okay, half a smiley face. Oh, sorry, negative. Yeah, sorry, my bad. Somebody pointed out to me, negative is like this. Sorry, not in my right mind, my bad. Yeah, thanks for letting me know. Okay, but if it's equals to 0, it is half a sad face, half a smiley face, or it could be half a smiley, half a sad face. This one we call as inflection point. Okay, so we got our answer already. This point, this 2, 3 is a maximum point. Okay, you have to see the shape based on the positive and negative. Okay, part 3. Okay, part B, sorry. Find equation of tangent again. Okay, find equation of tangent again. Wait, somebody asked, when equals to 0, should we sketch out the 2 of the inflection point? Don't need, you don't need to. The sketch actually no marks on in this case because they didn't ask us to sketch the graph actually. So normally they see your value here, you get the correct value, and you also maybe put out your why do you think it is a sad face? Okay, you get 1 mark here and 1 mark here. Okay, but you can draw. Okay, you can draw one of the inflection point is okay. Don't have to worry, is it which one? Next one. This one's straightforward. Straight away tell you about tangent. Find tangent. Quickly tell yourself, to find tangent, I need gradient and I need a suitable point. Okay, this is an SPM question. Gradient, people ask you find equation of tangent, you use gradient of tangent, please. Okay, people say at this point, then you use this point, please. You see not? I know exactly what I need, I know exactly what I need. And I'll just focus to find out these two. With these two things, confirm you can find any straight line, whether in AdMaths, whether in ModMaths. Okay, straight line, you just use this. So I'm going to differentiate the curve because MT is the same as dy dx. Power times power minus. Differentiate 4x minus 2. The gradient of 4x minus 2 is just 4. So that's why when you differentiate, you find the gradient is just a 4. Next one, we sub x equals to -1 because I want to know what is the gradient there. My MT or my dy dx will be 6 times -1 plus 4. Okay, we got everything we need. Let's put together in here. I use this for any straight line you do in coordinate geometry before. Okay, can. The next one is when things get a bit interesting. Okay, the next one is when things get a little bit interesting. Should we just use y equals mx plus c? Can also. But you all learn this in AdMaths. Okay, that's why I prefer to use this because it straight away gives me the whole equation. I don't have to separately find out the c first and then put back the c in. But can y equals mx plus c is okay. Right? You should get the same thing. You can try and see. You guys can try and see. Okay. This question, slightly older, in SPM 2018, it came out. It was the highlight of the year, one of the highlight questions of that year. Why? Because it looks so capable. It looks very capable. But later you'll see the working. Later you'll see the working. You will think that it actually is not so crazy. So the diagram shows the front view of a part of a roller coaster track in a miniature park. The curved part of the track follows an equation. So this curved part follows that equation. Point A is the origin. Origin meaning this point is 0, 0, meaning your x and y axis will be here. Okay, your x-axis is here, your y-axis is here. And then find the shortest vertical distance from the track to the ground. Shortest vertical distance. So this is your ground level. See if you guys agree with me on this. The shortest distance from the ground is not here, is not here, is not here, is not here. The shortest distance from the ground is here. Agree? Shortest distance from the ground. Shortest vertical. Vertical meaning like the y-axis like that. Vertical is like the y-axis. Now, What is so special about this point? What is so special about this guy? Right? So somebody has said it. Somebody has said it. It's a mean point, minimum point. Okay. So maybe something a bit difficult or a bit different about this question is that I don't see the keyword. I don't see the keyword literally. There's no minimum like that to show you. Okay, they didn't say minimum like that. But they did say shortest. The word shortest gives you a hint that shortest means the smallest, smallest meaning the minimum, right? So sometimes they can use the synonyms of minimum, right? So shortest is also a keyword. Shortest is also a keyword. But let's say if you didn't see the word shortest, you will know that it's here. And like some of you said, something special about this point is that it is a minimum point. So sometimes they don't write in the sentence. Maybe they give you a diagram and you have to look at it and see that, hey, yeah, this one is called minimum point. Okay, can I? So I want to find out the minimum point of the curve. Okay, I want to find out the minimum point of the curve. Yes, okay. So we are going to do dy dx for the curve, and then we are going to equal to 0. I have a very clear direction because of the keyword. Okay, dy dx equals to 0. So I'm going to take the power and times. Okay, power 3 times 1 over 64. And then the power minus. Same thing. The power 2 I times, I'll get negative 3 over 8. Use calculator if you need to. And then the power minus by 1. Okay, and then now we are going to find out what is my dy dx equals to 0. Why I know I need to do this step? I already knew it from the start, you see. So I want to tell you that for me, if I were to do it as a student, that is how I'm going to approach my differentiation questions. I need to know, okay, this one is differentiation, but which part of differentiation is it? What should I be applying? I don't want to simply apply anything. All right, so we try to solve this. First thing we can do is maybe I get rid of the 64. Okay, I write first. Okay, maybe I go and times everyone by 64 because I don't want the fraction to be there. Okay, then it would become 3x squared minus 24x equals to 0. Okay, and then I'm going to factorize out 3 and x, which I will get as x minus 8 bracket equals 0. Okay, so we have two possible answers. One answer is that 3x equals to 0, so x is equals to 0. Okay, one answer is x equals to 0. Another answer is this one is equals to 0, so my x is equals to 8, right? Or this you'll do a lot before. Okay, do you think x can be 0 or not? If we say x equals to 0, we are trying to say this x coordinate here is 0. I don't think here is 0 because 0 is right here, you see. The 0, 0 is here. Correct. So this cannot be 0. It has to be your 8 lah. Okay, this x has to be the 8. So you know what I'll do? I'll just maybe cross out this x equals to 0 and I'll reject the x equals to 0. I'm not going to use it because 0 is here. It's not here. Okay. So, but how come we have two answers? Why I do dy dx, I got two answers. I want you to take a look at the curve again. Do you see that on this curve, actually, we have two turning points. One of the turning point is here on the curve at this point 0, 0. Another one is here at 8, something. Okay, that's why you got two answers, because there's actually two turning points. Okay, at last, I'm going to sub x equals to 8 to find out the y. Okay, use calculator again. I'll get negative 4. Meaning all this coordinate here is 8, negative 4. So you see, guys, I want to show you something. I haven't finished answering the question, but out of 6 marks, just by knowing dy dx equals to 0, this part itself would have already gotten you 4 marks out of the 6 marks. Just by knowing how to do dy dx equals to 0. It would have gotten you most of the marks. Okay, how come I know I need to find out the y coordinate is because I need to know what is the height on the y-axis. Here is a negative 4. Okay, and then they say this is 5 meters. let me see as -5. The shortest distance, which is here, okay, a bit messy here, you know. Okay, the shortest distance here would be a 1. You don't need to do working also can, right? Or you want to do 5 minus 4 also can. It will just be 1 meter. Can see? So most of the marks is here because you know how to do dy dx equals to 0. It would have gotten you that far. This one will give you 1 mark. This one will give you 1 mark. You can use calculator to differentiate and integrate straight away, but it can only be done if you want to sub in an x value. Okay, I will not go through that because we are lacking a bit of time. But you can always YouTube. YouTube will be your best friend. Yes, those who got shortest distance is S1. Good job. Okay, very good. Okay, very good. Okay. I think for question number 5, right? For question number 5, maybe I'll just go through the keyword. Okay, maybe I'll just go through the keyword. I will do the working for you later on because I really want to do question 28. Sorry, question number 6. My bad. Question number 6. All right, I really want to do question number 6. So for question number 5, part A very simple, but part B, what do you all think is the keyword? Actually, while you answer, I quickly do part A first. Part A very easy. Approximate change. Very good. Approximate change. Can see. So you go through that list. It is the last guy on the list. Approximate change. Or they say the x change from here to here, and it's a small value, small change. Okay, so small change, approximate change. They are telling you that your working must have this, must have something like this. Okay, so this delta, this musical symbol looking thing is delta. Delta meaning the change. Okay, delta meaning the change. So say if we have x equals to 2 and it becomes 2 plus m. They say x change from 2 to 2 plus m. That means how much your x has changed is 2. Sorry. How much your x change is a m, my bad. From 2 become 2 plus m. That is a m. Okay, that is a m. All right, so that is how much your x has changed. Question is looking for how much the y has changed. But they ask in percent. Sorry, they ask in percentage. Okay, so later we think of how to do the percentage. But right now, right, you see, I'm looking at this formula that I know I must use. I want to find delta y. Delta x I got. Dy dx I think I also have. I can use this value of 10. Okay, I can use this value of 10. Let me tell you why. Okay, for our dy dx, we always sub in the original value. Okay, always sub in the original value. The original value of x is 2, and from 2, it changes to become this. That's what they say, right? Original value is x equals to 2, which we have already done, you see. We already go and sub x equals to 2 in part A. So part A is actually trying to help you a bit. Okay, so that's why I can use the dy dx value of 10. So my delta y is what I want to look for. Delta x is, just now we say already, the x changed by m from 2 to 2 plus m. How much did you change? You go and plus the m. Okay, sometimes can be minus also. Okay, delta y over delta x equals to dy dx. I'll use 10. So my delta y is equals to 10m. Okay, so we got our change in y already. Okay, now we are going to look at how do we find out the percentage of change. Before I do percentage, let's say a cup of bubble tea has increased its price from RM5 to RM7. Okay, if I ask you what is the percentage of change, okay, do you guys agree? See if you agree. How much it has changed is 2 ringgit. If I want to find the percentage of change, I would take 2 ringgit divided by 5, not 7. We divide it by the original value. You want to find percent, you times 100%. Okay, so on top here, we have the change. Maybe I read that. Basically, on top, we have how much it has changed. At the bottom is always the original value. This is how you always go and find percentage of change. Okay, Ken? We already know how much it changed. The Y changed by this much. But if I want to find out the percentage of change, right now, this one got 80. The original value is missing. Okay, the original value of X is equals to 2. What is the original value of Y? You go and just sub it to the equation here. You just sub X equals to 2 in, you will get the original value of Y. Cannot. So the original value of X will give you the original value of Y. You sub it into the equation. Oops. Okay, so we get the Y original as 11. The original value of Y as 11. So the percentage of change in Y would be how much the Y changed divided by the original value of Y times percent, 100%. I'll get 90.91 M. I know the M is a bit annoying there, but don't worry about it. You just write it at the side. And that is our final answer. Okay, that is our final answer. Looking at the time, I think I have to start integration already. But integration is a bit more straightforward, right? Maybe shall I just highlight on a bit of keyword in question number 6, but I will show you the working out. Okay, I'll write some explanation there also, and I think you'll be able to understand the working. Okay, later on. So we just quickly go through. But okay, there's this whole paragraph of words, right? Very, very long. Okay, very, very long. But if I look at part A, the keyword lies here. You all know what to do with it. Okay, 5 marks. This one came out SBP last year. If I look at part B, what is the keyword in part B? This one we haven't done before yet. The keyword in part B. Rate, very good. You see, not only got one time they write the word rate, 2 times. Okay, got so many rate, and then that's all. Okay, but to do rate of change question, since we haven't done it yet, right? Yeah, so you're right. Rate we have to use chain rule. Must use chain rule. Okay, this minimum we will go and differentiate the cost, and then equal it to 0. That means in part A you actually need to go and make the cost equation, make the equation for the cost. Because people would think, hey, got area, I can differentiate this area because I see minimum. Don't simply differentiate You need to differentiate the cost because you want to find minimum cost. But in part B, right, they say the water flow at a rate of like this. Do you guys see that meter cube per second is actually volume divided by time? Okay, meter cube per second is actually volume divided by time. Okay, volume divided by time. So this is what we call as dV dt. When I write dV dt like this, it means that we are talking about the rate of change of the volume of the water every second. This means how much volume is changing as time changes. dV, D means difference, or D means the change in V. Okay, the change in the volume. D means difference or change. They are similar meaning. The change in the V as the time changes, as the time goes by. So this is how much the volume will change as time goes by. Okay, then they ask you to look for the rate of change of height of water container. They're asking you to look for how much the height is changing as the time goes by. So usually when they use the word rate, it is relating to time. Rate means how fast or how slow. It is related to time. And you have to write the chain rule for this. Yeah, I just go through how to write chain rule in case you guys don't know. So based on the chain rule, you will need to remember that chain rule always just means that you are trying to split up your DH and your DT into 2 fractions. You split it up into 2. So what I mean by splitting up is that You put your DH here, just copy and put paste. You put your DT here, just copy and paste. But you must split it up into two fractions. You cannot put DH and DT again. You just DH and DT and then you open it up into two fractions. You can see, DH, DT, and then you open it up into two fractions. Then what do you need to put in the blank space here? Okay, what to put in the blank space here? Very easy. Just look for any other D's that you have in the question. So far in your working, you wrote DH, you wrote DT, got one more, DV, right? You wrote DV also. That is the one you need to put in. So you just go and find still got what D what? DV, you can put in. Okay, you can put it in. This is your chain rule. So you just need to go and find both of these things, this one and this one. Then you can find out what the question wants. The question wants you to find DHDT. Okay, so don't worry, later on I will do the working and then you'll see, I believe you'll be able to understand it. Okay, I'll write it step by step. Okay, this question is a super duper good question because there's so many keywords. And you should now be more confident to know immediately what I need to do. Part A, Part B, Part C. Okay, whole thing is 10 marks. Came out in SPM. This one came out in SPM 2019. Okay, not too long ago, but it's a very good question. I will let you guys try it also. Later on, you check the answer, okay? The solution. Let's move on to integration, shall we? Okay, we still got about 25 to 30 minutes left. Let's go through integration. So I've already taught you how to integrate. Now, these three things are the most commonly tested things. Let's start with quickly the characteristics of definite integral. Okay, so this one basically just says that if you go and integrate from A to A, okay, if you go and integrate from A to A, same point to the same point, you will just get 0, right? That means later on you integrate, you need to sub in A minus, and then you sub in A again, you get 0, right? So most of you will know that for the area, if you integrate from one point to the same point, you don't get any area, all right? Then what if you want to flip this two? You can flip, but you need to put negative. Okay, we just go through first. Later you see how to apply. Later we see how to apply. Later, if we have, sorry, the third one, if we have a number multiplied to anything, this number never affects your integration. Just pull it up. It can always be pulled up. Okay, next one, if you have two like this split up, sorry. If you have, my bad, integrating the fx from A to B, then B to C. It is from the number down here to here. Imagine this. I have a curve, fx. If I integrate from point A to point B, and then point B to point C, point B to point C, this is what I'll get. This is the area that I'll get. It's the same thing as integrating A to C. Okay, A to B, B to C. It's the same thing as A all the way to C. Okay, last one. If I integrate two different things, there's a plus and minus in between. I can always split it up. Okay, I can always split it up and say that I'm integrating the fx first, plus I integrate the gx, so I can split it up. Okay, shall we quickly see how to apply this few characteristics first? I want to do maybe question question one. Question one. Later on, they will send you the answers. Later on, they will give you the full solution. After the session here, maybe tonight, I will complete all the solution and then I will send. And then you guys will get it. So I think, if not mistaken, through email, but you all can check with the admin. Okay, so number one, they say integrate fx from 1 until 3 will give me a value of 5. So the problem is we don't know what is fx. Okay, we don't know what is fx. So you have to go and integrate this by using this piece of information. That is when, so I copy the question first. They look different. Okay, they look different. The 3 and 1 is not at the same place. So I'm going to make them become like this. When you swap your limits, when you swap the 1 and the 3, it would be negativity. And then what is this green color thing? You see, it has a value of 5. It is equals to 5. So your exam want to see this. They want to see how you transform, become like that by using the characteristics up there that we have learned. Okay, can? Yes, very good. You'll become a 5 and then end up -5. Then part 2, I copy the question again. For this one, I got this extra 4 here that I don't want. So I have to go and split them up. You show to them how you split. Okay, you say you integrate the fx first, and then plus integrate the 4 later, like this. Why I want to split? Because this one look like the green color one again. See now? Which has a value of 5. Okay, let me tell you the common mistake here. We see that it's 5. Our hand very itchy. You know why? Because we are so not used to seeing a question that don't require us to integrate. So what will happen? Why do I mean by itchy? Your hand become very itchy is some people will think, hey, I haven't integrated yet. You know what? Let me go and integrate this lah. Okay, let me go and integrate this lah. The moment you do that wrongly, you must understand that 5 is the answer of your integration, has been integrated, done for you already. You don't go and integrate again, and don't go and change, don't go and sub in 1 and 3, because you can actually integrate when you integrate, it become like that. Okay, this will be wrong now. Please understand that 5 is already the answer, integrated for you, integrated and sub in already for you. So don't need to touch anything. Meanwhile, this one you have to integrate. Okay, this one when you integrate, the 4 it will just be power plus power divide. So it'll be 4. It's actually 4x power 0 lah. Power plus become like this. Power divide is like that. But normally we don't write the 1. Okay, and then you get like this. So the 5 don't need to do anything. You sub in the 4 and the 1. End up you will get 12 minus 4, which is 8. Answer is a 13. Okay, next one. Question B. dy dx is this. Y is 10, x is 2. Express y in terms of x. Okay, in this case, we are doing dy dx and we are transforming back to y. Right, just now I told you you can transform from one form, go backward, if you go and do integration. You want to find y, you need to integrate your dy dx. Okay, you want to find y, you have to integrate your dy dx, which would be same thing, power plus power divide. You look at the power here, you plus the power by 1, and you divide the power. This one, power plus. Hey, sorry. This one will have a plus c. Okay, I'm assuming that everyone knows why we need to plus a c. I don't have time to explain right now. But anytime when you integrate and you got no limits to sub in, no numbers to sub in, we always must put a plus c. Okay, we always must put a plus c. Okay, then we also need to go and find out the c where you sub in, say x equals to 2 and the y equals to 10. Okay, so y is a 10, x is a 2. Okay. This is 10, this is a 10 also, 4 plus c. So end up c will become 4. Okay, there we have it. That is our equation of y in terms of x. Okay, y in terms of x. Again, question number 2 is very similar. Question number 2 is very similar. So I'll let you guys try that later. Okay. Someone is drawing on the screen. Yeah. How do I clear it? Okay, I think okay. Okay, we continue. So question number 2, I will let you guys try later on and see. Question number 3. Question number 3 is quite interesting. But I think that one I can explain with my solution later on. So I think I want to do at least one question that talks about area and volume. Maybe we can look at question number 6 first. Okay, we got time, we do the others. Question number 6. Okay, let's see. The given diagram shows the straight line y equals to x plus 6 intersect the curve. So straight line will intersect the curve at point A. Find the coordinates of A. So before we go and find coordinates, before we actually answer this question on that talk about coordinate and area and volume, I want you guys to take note on this. Whenever you want to integrate towards the x-axis, always remember is dx. Okay, dx. That is how you decide whether you want to do dx or dy. Meanwhile, this guy in front here always tells you what you need to make as the subject. Okay, say you want to integrate to the x-axis. If you all don't know what I'm talking about, integrate to the x-axis meaning look like this. This is the area you get from the curve to the x-axis. Integrate to the y-axis meaning it look like this. Can you see the difference? Okay, this is dy, this is dx. Right, so this is what you need to make as the subjects. Okay, let's say you want to do dx and then you know it is y dx. But maybe the equation of the curve they gave you was x equals to 3y squared plus 4, for example. But you say you want to do y, then you need to make y the subject. You get it? So the formula will tell you who to make as the subject. Okay, you need to try to get a y equals to something, 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 and then sub in this. Right? So you must remember it's y dx and x dy. For volume, whether is it 180 revolution or 360 revolution, it is the same. And the formula also the same. If they say x-axis, you must do dx. Y-axis, you must do dy. You just have to add two things. Same as area, but add a pi, add a square. Add a pi, you see? Add a square. That's all that is different. Most of the time, you don't even need to imagine how the 3D shape look like. Okay, you just need to know how to use the formula can already. But something again that not in your textbook, maybe your teachers also don't highlight to you is this extra tip. Okay, just like in circular measure, I say triangles is going to help you when you are stuck. That's what I said, right? Most of the time, yes. Most of the time, yes. And also a lot of people always forget, because you are dealing with integration that has x-axis, y-axis, got all the point, and then sometimes cut with another point. Therefore, we deal with a lot of coordinates as well. Very, very popular. Okay, we deal with a lot of coordinates as well. You need to know what are the coordinates in order to know, say, from where to where are you integrating. You need to know the coordinates so that you know between this curve and this line where they intersect, because maybe the area in front here is a triangle. Maybe behind here I need to integrate. So the coordinates are useful for me to know where to where I need to integrate. Or maybe it helps me to find out the area of this triangle. I know the base and the height and all that stuff, right? So two very important ones. If it's an intersection between two equations, you do simultaneous equation. You sub in 1 into 2, that kind of stuff. Maybe a curve cut with another line. You go and sub in equation 1 into equation 2. You sub these two equations into one another. But if it's the x and y intercept, all this is actually revision on your coordinate geometry. Say if you have a curve like this, you want to know this point, you want to know this point. Always remember on the y-axis, immediately you know your x coordinate is 0, 1. On the x-axis, immediately you know your x has a certain value, but your y will always be 0, 1. Okay, so if you're on the x-axis, you will have some x value, and the other one, the y will be 0. So it's always the other one that is 0. This one is basic knowledge already. Everyone need to know by now. Everyone need to know by now because you confirm will need to use it. Confirm you will need to use it. All right, so let's try and see that question we do together, this whole thing. First one, find coordinates of point A. Okay, what's so special about point A? It is an intersection point between this guy and this guy. Okay, what I'm going to do is I'm going to call this as my equation number 1, let's say. Call this as my equation number 2. And I'm going to sub 1 into, just like how I summarize at the front for you. Okay, say maybe you all don't like the fraction. I think a lot of us don't like the fraction. You can times everybody by 4. 1 over 4 times 4, it will just become a 1. 3 times 4, 12. 4 times x, 4x. 4 times 6, 24. Okay, and then you get a quadratic equation. Arrange nicely. X squared first, and then your x, and then you move 24 over. Calculator if you need to. 12 minus 24 become minus 12. Okay, the rest you all know what to do. Factorize. You will get these two answers. Yeah, most of you I know will factorize using your calculator, right? Can also. So you get two different answers, but you know that point A, right, has a x coordinate of -2 lah. It cannot be a 6 here, huh? It cannot be positive 6 here. Not logical, right? Not logical because it's on the left side of the y-axis. Okay, so I know point A would be, the reason why I got two answers is because actually they didn't show you, but this curve, if I extend higher a bit, this line, if I extend higher a bit, it will intersect another place. Okay, and this one will be at x equals to 6, right? But we're not interested in that. Okay, so we continue. We say that, okay, I know my point A is -2 comma something. How to find out that something? Huh? You go and sub it back to find the y. You want to find y, you sub into any equation also can. Okay, so your point A is actually -2 and 4. They are asking you to find this for a reason. We will need this one. Okay, we will actually need this -2 and 4. Okay, -2 and 4. Then find the area of P. For area, I want you all to focus like this. Huh? A lot of students, they simply integrate one. Huh? They will try to do dx or dy. So it's always x dy, y dx. Okay, what do I mean by they simply integrate? Meaning you don't know where you want to integrate. You just think, okay, it's always the x-axis, because most of you prefer the x-axis, but sometimes doing the y-axis can be easier. So how do I know like which one I would prefer, right? Okay, first thing that I want to tell you guys, there's only two options, x-axis or y-axis. If one don't work, you try the other one, right? If one don't work, you try the other one. But where is a good place to start is to always look for the curve equation, always look at the curve equation and see which one is the easiest subject, easiest to become a subject, or sometimes it is already the subject. Can see it. Sometimes the curve, they already write something as the subject. Not all the time they are so nice, but most of the time they're quite nice like this. So you try to do first the one that is easiest to become the subject first. Sometimes you have to move around. Okay, don't go and kill yourself and try to make x the subject. You make life a bit more difficult. It's possible, but you make life a bit more difficult. So you try this first. 95% of the time it will work. Really cannot, okay lah, no choice, you try the other one. After all, there's two options. Okay, but at least you know I will try this one first. Okay, so my area of the curve, my area for the curve, I know I'm going to do this. Now, next one. So I'm going to focus on the curve, and I always will tell my students, you all go and draw a few points on the curve. And if you say you want to do dx, if you say you want to do dx, you go and integrate down until you touch the x-axis. Curve to the x-axis. Okay, you take a few points and you don't simply draw. You don't draw from this line and don't draw from this line. Don't simply draw. You draw from the curve. Okay, you draw from the curve, right? Because now I'm focusing on the curve first. But I know I don't need all this. I take my eraser and rub off. I don't think I need this part also. I take my eraser and rub off. Okay, it looks like the part that I only want for the curve is here to here. Because in front here look like a triangle. And I think finding area of triangle is quite easy, right? I think finding area of triangle is quite easy. So let's focus on the curve first. I will integrate the y. What is y? Y is this. And I'm going to integrate from, if you're doing x-axis, you make sure you go and look at the x-axis for your limits. X-axis, don't go and look for the y-axis. Sometimes some people will make this careless mistake. They go and read the y-axis because sometimes you got too many coordinates, you get confused. Okay, the x means it's everything about the x-axis. So you are integrating from -2 until 0. From -2 until 0. Let's go and do this. Power plus, power divide. When I say divide, I just put down here good enough. As long as you put down there, it means divide already. So you don't have to whole thing divide like that again, actually. Okay, it will be easier to manage. And then you sub in 0 lor. And also you sub in -2. You get 0 minus . Now, this is another careless mistake. At some point, I've done this. I maybe myself also have done this mistake before, which is sometimes sometimes we will forget that here got a minus, but the formula also requires us to minus, and then we will forget about this, and then we will forget to minus. Okay, so the minus will actually become a plus, right? Because some people will go and write like that, right? But it's minus, which will become a plus. So the purple color area is 20/3. Okay, the purple color area is 20/3. Now we go and look for the green color area. For this green color one, like we say, it's just a triangle. Okay, it's just a triangle. So I can just use half times base times height. The height is 4, because this point A just now we found out is a 4. But I don't know what is the base length here. Those of you who are sharp, you all will know we need to go and find out this point first. Okay, we need to go and find out that point so that I will know from that point to -2, how long is the base? Okay, how long is the base? What's so special about this point? Guys, can you tell me what's so special about this point here? What kind of coordinate is that? Yeah, it is the x-intercept. We call it the x-intercept. You sub y equals to 0. Go and look for the x. Yeah, immediately you know y is 0. Go and look for the x. And then you all please don't get confused. Don't simply sub in. You sub into the straight line, this one. Okay, you sub into y equals x plus 6, because it is the x-intercept of the straight line, not the curve. Sub y equals to 0. Okay, then you get y. I sub it into equation number 2, because I already called it equation number 2 just now. Okay, so here is -6. We can find out the green color area. Here is a 4. Here's -6 until -2. That means here also will become a 4, you see. So the area of this triangle is half times base times height equals to 8. Okay, the total area will be like this. It would be the purple color 20/3 plus the green color 8, and we will get 44/3, or you want to write it as 14 and 2/3 also can. Okay, yep. Now volume. Okay, now we want to do volume. Quick one, last one. Volume, in my opinion, is slightly easier than area, because the question will always tell you which axis. Find the volume when the shaded region Q is rotated 360 about the y-axis. If they say y-axis, immediately think of dy. If you do dx, confirm whole thing gone case. gg.com. Cannot confirm, you get wrong answer 100%. You must follow the question for volume. Must follow. Please, if you don't follow, you are throwing your marks away. Okay, you will do everything bersusah payah, and then you get an answer that's 100% wrong. The whole thing will be marked wrong. Confirm wrong. The moment I see you write the wrong d, dx, I don't even need to mark. Confirm wrong already. Okay, it is x squared dy, and don't forget the pi. Okay, all right. So volume, you follow the question, and then they say integrate to the y-axis. Okay, I'm gonna rub off a bit because look a bit messy here. Yeah. But basically, we are taking the curve and we are drawing it to the y-axis. Go to the y-axis, right now. Go to the y-axis. Okay, go to the y-axis. So I don't know where it starts from though. I know this point is 4, but this coordinate I don't know is what, right? So maybe I go and say that point there, okay, I'm integrating from here until here. The point there is actually x equals to 0. Right? I think this one you're quite good at. Just now you can tell me at any time is on the x-axis, y-axis. You all notice or not? Your textbook never teach you to find coordinates. They didn't say it's part of the chapter. But the question always requires you to find coordinates, because if you don't have the coordinates, you cannot solve, you don't know where you want to integrate. So coordinate is a hidden part in area and volume that is always, you always need it. It's always tested, but in a hidden way, right? In a hidden way. So I'm going to sub x equals to 0 into equation number 1 into the curve, because I'm looking for the curve one. So y is equals to 1 over 4, 0 squared plus 3, y equals to 3. So here's 0, 3. Okay. So let's say I want to find out the red color. Let's try to do area first. Let's see what we will do. To find the area, I'm going to do the sorry, I shouldn't confuse you. Okay, you know what? Let's do volume. My bad. Okay, when I teach in class, I will tell my students that it's very similar. So I'll teach them to do area and then to show them how similar is it to volume. But I think we don't have the time. Okay, so I'm going to follow this volume formula, and you must follow very carefully. Who to make as the subject? This guy. Okay, you take your curve, you must make x squared the subject. So first step, you need to move your 3 over. Second step, you need to get rid of the 4. Everyone you times 4. Okay, so it'll become 4y minus 12 equals to x squared. This is what you want to integrate. Okay, this is what you want to integrate. Okay, this is what you want to integrate. So we are to find out the volume, you are integrating x squared. What is x squared? 4y minus 12 dy. We are dealing with the y-axis, and we are integrating from 3 until 4. You see? So you see, I follow carefully. I'll make sure that I'll get the answer for sure. Power plus power divide. The pi won't kacau your integration one, because the pi is just a number, right? Pi is just 3.142. So no big deal. Okay, let's quickly get our final answer. Negative 16 minus negative 18. And it would be a 2 pi as the final answer. Okay, if you want to write the units, it'll be unit cube. Okay, 2 pi. 2 pi is the final answer. Okay. How to get this volume formula again? This one not given, so you have to remember to that the area is y dx or x dy. Okay. For volume, you just have to go and add 2 things. You see, I copy the same thing, but you just go and add 2 things, add a square and add a pi. Cannot. Okay, so yeah, that is our time, 2 hours here today. But I hope you guys have learned something, that when we do our integration, right, when it's area, I always think about which one is the easiest as a subject first, and then this formula will guide me, right? If y is the easiest subject, I will do dx, y dx. If x is the easiest subject, I'll do, oh, sorry, I'll do x dy. My bad. Sorry, guys, I made a mistake here. Please correct this if you copied. Sorry. Right? And then for volume, you must follow the question. They say rotate around y-axis, then it's dy. Okay, you will need to follow which axis. So the dx or dy will tell you which axis. Meanwhile, and also the coordinates very important. Okay, coordinates, we use coordinates a lot in integration. Meanwhile, in differentiation, I taught you how to look for keywords. I see rate, confirm, I know got chain rule. I see approximate change, I know confirm got this in my working. But it doesn't have to be x and y. Sometimes it can be other stuff. Like for example, sometimes it could be the area and also the radius, that kind of stuff. right? And I see minimum, I would think of this. So the least that I hope for today, at least you have a certain direction. You don't feel so lost when you read the question and try to tackle the question. You have some direction. You try to differentiate a bit, try to integrate a bit. Hopefully you'll get something done. All right. So I wish you all the best. I will end our session here today. And okay. And good luck to you guys. Good luck to you guys.